In this session, I'm going to build a support vector machine learning model. So we are going to consider this data set, which is voice.csv file. Okay. So these are the features that we have, and this is the dependent variable. So let me import libraries. Let me import the basic packages. So import numpy as np, import pandas as pd, import matplotlib.pyplot as plt, import clog as SNS. So these are the basic packages that we require. Okay, so let me import the data set first. So data, let me give the variable name, data frame name as data. So pd dot read underscore csv of. So I will paste the path here. So this is the file name, and I'm going to paste over here. So let me get the top 5 rows, okay, of the data set, data frame. So here is the data frame, and we have the top 5 rows of our data frame. So these are the independent variables. So all the features you can see. So all are in numerical and it's scaled. And the label that is our output target, which is a target, is dependent, which is in a categorical variable. Okay. So what will do is that first let's check the shape, that is the number of rows and column. So the number of rows are 3,168 rows we have, and we have 21 features. Okay. So first, let's check for correlation, if there is any correlation. Okay. So data dot core. This will give the correlation if there is any correlation in our data set. Okay. So let's see mean frequency, it's negatively correlated at SD, and median 0.925. Okay, so this is the correlation values over here. You can go through these values. I mean, it's not of much use for us for now. So now let's check for null values. Okay, is there any null values in our data set? Okay, so data dot is null dot sum. So you can see that we don't have any null values in our features of that independent variable. So we can check now. What we can do is that let's do the feature selection. So let's take x variables, the predictors in our x, and the dependent variable or the target variable in y. So x is equal to data dot iloc of, I want all the, I want all the rows. I want till the last column. Okay. And y variable will contain data of, so I want on the label. Okay. I want the label data. So the column name is label. So data of label I want. Okay. So let me print x dot head. So this is the head variable. Like these are the independent variables or the features predictors we have. So let me print y as well. Y dot head. So these are the values we have. That is the label or the target variable. So before performing this, I wanted to show you the shape. I mean, total number of rows we have. We have already seen that we have total number of rows is 3,168. So let me print that one as well. So print data dot shape of 0. Okay, so we have 3,168 rows. Print data of label. So data of label is equal to, so what we want, data of label is equal to male. So I will, so this will pass, so we print true or false. I will print it in. So I will pass this in a data frame data. So I want the shape of this. So I have so I have 1,584 males in our data set, and let me check for female as well. So label is equal to female. So we have 1,584 females in our data. So it's equally distributed. Okay. So now what we can do is, so we have done the feature selection part over here. So let's move to the next part, that is scaling and encoding. So you know that our label data is a categorical one. Okay, so we have to convert it to numerical one so that our machine will be able to process it. Okay, so for that we have to do scaling and encoding. So from sklearn dot pre-processing import label encoder. Okay, so we have imported label encoder. So let's instantiate label encoder into gender as a name called gender encoder. So we have given the variable name as gender encoder, and we are instantiating it to label encoder. Okay. So now what you can do is that, so we know that our y, our output variable, is in the form of categorical column where we have male and female. So we have to do the encoding for that. So one second, we have to encode. So we have to do the encoding. So I will call it y here. Y is equal to gender encoder dot fit transform. I will do fit transform fit underscore transform. I will, so that we have numerical values for male and female. So I will pass here label gender encoder dot fit transform of y. Okay. So let me run y and check the values. Okay. So gender encoder. Okay. So there is some problem. Gender encoder dot transform. Okay. So we have got an array of values over here. So now let's scale the data. Okay. So we could see right here we have the features they have some different scales. So we can see here it values lies in form of 0.01 like that 0.1. So here we could see 274,224 is there. So all are not in the same scale. So let's scale them in the same range. Okay. So for that, what we have to do is that from sklearn dot pre-processing import standard scalar. Okay. So let's instantiate standard scalar here. Scalar is equal to standard scalar. So we have instantiated standard scalar. So now let's uh, do the pre-processing part where we will scale down the values. Okay. So let's do fit transform on our data. So fit will give mean and standard deviation for that particular columns. For each particular column, we will have a mean and standard deviation. And when you do the transformation, it will give the z-score, okay, values, okay. So let's do the fit transform. So let's take x is equal to scale. So I have given scale, right? Let me call it a scalar, okay. Scalar dot fit underscore transform. So fit transform of x. So print x, or I mean, let me pass x over here. Okay, so these are the arrays of values. So we have scaled down the values of each of the columns that we have. So all the columns have been scaled down. So all are in the same scale. All the features are in the same scale. So now let's split the data into train and test. For that, we have to import train test split. So from SQL1 dot model selection import train test split. Okay, so I have imported train test split. So I will call x train comma x test comma y train comma y test. So we'll pass train test split. This is our model cell. So this is used for splitting our data. So I will pass X, I will pass Y, and also I have to pass the test size as well. So test size, I will pass it as zero point 0.2. And let me give a random state. So random state is equal to 10. We give 10. Okay. So we have done the splitting. So we have splitted the data into train and test. So now so now we use support vector machine. Okay, so now let's build our model. So from sklearn dot svm from sklearn dot support vector machine, we're importing support vector classifier. Here C is the classifier. Okay, so since we are considering a classification problem and not a regression problem, so we are importing SVC, that is support vector classifier. And also, we might need this matrix. So we want to check the accuracy as well. So from sklearn dot, so from sklearn we import metrics. So I will instantiate support vector classifier. So SVC is equal to SVC. So now let me train our model. Okay, so we have our training data, right? So let me train our model. So SVC support vector classifier is our machine learning algorithm dot fit of. So I'm going to train our model with X train, comma Y train. So we have done the training part. So now let's do the prediction. Okay. So let me call prediction Y train is equal to, so SVC is our model. So we have trained our algorithm and we have our model is ready for prediction. SVC dot predict of, we will pass X test. So and we got the prediction part. So let's print metrics. So metrics dot accuracy score of, I will pass Y test comma Y prediction. So let me run the score. So you could see that we have a 98.58% as our accuracy score. We have to know that here what kind of uh, parameters we have. Okay, so let's see the support vector classifier parameters. Okay, so the kernel we have used here is RBF. So what is RBF? So let's see the PDF we already seen. So support vector classifier, we have seen that there are different kernel functions available, and we are using RBF kernel, okay, which is a radial basis function, which is a Gaussian, okay. So the kernel function we are using is a Gaussian RBF, which is radial basis function. So this is RBF we are using. So by default, the default hyperparameter for support vector classifier, support vector machine with default hyperparameter is the kernel is equal to RBF. And also you could see, you have to see that the C, the regularization parameter here by default is 1. Okay. So we can change the value of that as well. And degree is 3 and gamma is scaled. Okay. So you don't have to worry about other parameters. Just consider these two. Okay. So for now, just we have a regularization parameter as 1 and kernel is RBF. It is radial basis function. Okay. It's radial basis function. So we have seen that. Okay. So now what we have to do is that, so we have our model with accuracy. So now let's build another model. Okay. I mean, another model in the sense. So let's build a pass kernel is equal to linear. Okay. So let's copy this code. Let's paste it. And here, what to do here? kernel is equal to, so let's pass linear and check. So we have passed linear kernel here. Okay. You could see here in this parameters, so what kind of parameters, hyperparameters, or the what kind of parameters we can pass for kernel. So let me check that. So kernel, so we can pass linear, polynomial, RBF, radial basis function, sigmod, and pre-computed. Okay, so now let's see the accuracy score. Okay, so here the accuracy has decreased. You could see, right? I mean, the accuracy has decreased from 98.5, almost 98.6% to 97.8%. Okay. So let me use polynomial as a kernel and check what's the accuracy we get. So here I will pass POLY poly, which is our polynomial. So 95.8%. You could see that our model that we have created has decreasing accuracy for various different values. I mean, it's behaving really good. I mean, our model is giving a very accurate result for kernel is equal to a radial basis function, which is our default one, and it's not giving that much good results for linear or even the polynomial. So now what we can do is that let's do optimization of hyperparameter. Okay, hyperparameter C. So you have seen that our hyperparameter, the parameters here, the C value regularization value is, so what is that? So let's read this. Okay. So in we have seen that regularization parameter, right? So where is that? So here we are already seen in the previous class, right? So yes, C is the so regularization C is the regularization parameter. So we have a regularization parameters of one by default. By default, it is having one. Okay. So let's pass some various values. Okay. So from sklearn, from sklearn dot model selection, import cross validation score I'm importing, so that we will do optimization of hyperparameter. So cross validation score. So C range I will pass. C range is a C range. Let me pass it as range of list of range of. So I will pass from 1 till 25. So we have values from 1 till 25. For accuracy score, I'm going to append into a list. So this is our list. Okay. So I'm going to append accuracy score. So we'll check for various value of say regularization parameter. What kind of accuracy? What is the value of accuracy? For I in C range. So I'm going to pass our support vector classifier, support vector classifier dot fit. So before doing that, we have to instantiate support vector classifier, support vector classifier of. So I will pass kernel here is equal to. Let me pass kernel as radial basis function. Okay, RBF itself. Okay, so RBF because it's giving good result, right? I mean accuracy is higher with that. Okay. So radial basis function RBF, okay, kernel is RBF, and C is equal to C. The C is here. I'm changing it to C. So C is our regularization parameter. So for various value of C, it will give the accuracy score. So scores is equal to. So now we have to pass cross validation score. So this is underscore. Okay, sorry for the mistake. So cross validation score. So first we have to pass the algorithm, which is SVC. Then we have to pass our X train. Then we have to pass Y train. Then we have to pass K-fold, which is CV, is cross validation. Okay. CV we have to pass. We will pass cross validation. We want 10 folds. Okay. So this will give 10 values, making sure what it does is that it for 10 folds, it uses all the 10 folds of data set for training and testing purpose, and it will give value, and we'll consider the mean accuracy score from that. So scoring what we want is accuracy. What kind of score we want? Accuracy we want. Okay. So let's see the parameters here. Okay. Now, So accuracy score, just append accuracy score. So what have I done is that in this cross validation score, we are passing the algorithm and we are letting the algorithm to train using X-train and Y-train. And we are making use of cross validation is tenfold so that each of the X-train data set we have is used for testing and training both. And it will give 10 values, I mean 10 accuracy score, and we will take the mean of that 10 accuracy score because we are taking each of the data set for of the training set crossfold for doing our prediction. So we will take the average of that. So we are considering scoring is accuracy because want to see the accuracy score from 1 till 25 values. Okay. So accuracy score dot append of so what can do scores dot I want the mean value. Okay. I want mean. So mean. So now let's print accuracy score. Let's wait for some time. This will take some time to print. So if you see this C value, okay, so for C is equal to 1, we have got the highest accuracy, I guess. So here we have 98.02%, and I guess that's the value where we have got the highest percent of highest accuracy score. So let's do the plotting and check, okay? So doing the plotting will help us to analyze how and where our accuracy is maximum, okay? And what value of C the accuracy is high. So PLT dot figure of fixed size equal to I will pass 10 comma 6 and let's have C values. We have C values, C range we have, right? So I will use that as our X value. So PLT dot plot of C range. So we have our C range. So I will use this X axis as C range and Y axis we know accuracy score. Okay. So now let's plt.x label. I will mention it as uh, value of C for support vector machine. That is value of regularization parameter for support vector machine. And plt.py label, we write it as cross validation score. Okay, so we are going to get the cross validate score. So let's run this code. So we have got the plotting and it can be seen that the value is really high when our C is equal to 15. Okay. So when C is equal to 15, we got the cross validation accuracy score to be maximum. Okay. So let's use that. Okay. So I will take that value, C value as C 15. Okay, so what we can do is that now let's take a C range. So C range is list of NP dot A range of, so I'm passing here uh, uh, that 15. Okay, so value is maximum at 15, right? So I will pass 15.1 is our starting value and I want till what? Let me say I want till 16. And in the steps of point 1, let's take. Okay. So now accuracy score I want. So I'm talking in the form of list. So now for C in C range, what we're going to do is so support vector classifier is equal to support vector classifier of I'm going to take kernel is equal to RBF again. RBF, let's check RBF, right? That's RBF and cross validation score C is equal to C. Okay. So scores is equal to cross validation score of, so I will pass the algorithm, I will pass x comma y. So previously, actually the thing is that you should have passed x comma y here. Instead of x train and y train, you should have passed x comma y. Let me check what kind of value, because we're not going to train the model right here. The mistake that I did over here is that I used x train and y train. So instead, you should have used x and y data. So let me run this code and check what kind of result I will get. Okay, sorry for the mistake that I committed. You should have passed x comma y, because here not we are not training the model. We are passing cross validation score. This is a model selection package, so you have to pass whole data set, right? So we have to pass x y instead of passing the so feature selection value. We have to pass the standard scalar. After standardization of data, we have to pass that value, standardize the value for model selection. So we had to pass that value for cross validation score. So my bad. Okay, so I will run this code. Let me check. Okay, if you see now, our value is maximum over here, right? You could see, right? I mean, between 0 and 5, between 0 and 3, I guess, accuracy is higher at this point. Okay, so what we can do is that, so instead of taking point 15.1, I'm going to take point 1 as a range, because it's greater than 0 and less than 1, I guess. I will take till 2, okay? 0.1 till 2 I want, and step size is 1, okay? I hope this is not wrong. Okay. So I'm going to build our model. I'm not going to build our model, but I want to do this cross validation score where I'm getting the higher accuracy. Okay. For our data set. So now we have x comma y cross validation score of a support vector classifier, that is our algorithm, and we have x, that is our features, and y, that is our target variable. Okay. So we have passed this thing, and we are passing cross validation is equal to 10. And now we have the accuracy score. So scoring. So let me see what is scoring over here instead. So scoring is none. So I'm going to pass scoring is equal to accuracy. So you could see here in the parameters, the various parameters that can be passed for scoring. So scoring, where is over here? So here, okay. So scoring can be passed accuracy over here in our case, okay. So now what you have to do is that, so accuracy score, the list, add that into list accuracy score. So append those values into the list. So I'll pass, and I will pass mean, okay? Because here also, you know that we have passed cross validation as 10. So you have to take the mean of that. And I'm going to print of accuracy score. So let me print the values. So let's check where we are getting the maximum accuracy, okay? So that value, we are going to take it wherever we are getting highest accuracy. So once again, we'll do the plotting. So plt.figure, control C. And so we have got the accuracy, and we can check from here. So wherever we are getting maximum accuracy. So we have passed C range. So C range and accuracy score. So let me plot again. So yes, you could see here, right? I mean, at a point 5, at point 5, we are getting maximum accuracy. Okay. So at point 5, we are getting the maximum accuracy. So we have got the maximum accuracy at C is equal to 0.5. Okay. So now what you do, let's do the optimization of hyperparameter gamma. Okay. So we have seen till C. Okay. We have still seen optimization of C. Okay. So what we have seen is that optimization of hyperparameter C we have seen. So let's see the optimization of hyperparameter gamma now. Okay. So now gamma score is equal to, so I will pass gamma score range, I will pass. So gamma range I will pass. So let's pass like values like point 001, comma point 1, 0.01, comma point 1, comma 1, comma 10, comma 100. Okay, so these values are enough. So I want the accuracy score for these values. So for I, for C, for gamma. So now we are considering for gamma in gamma range. So support vector classifier is equal to SVC of, we are passing kernel is equal to RBF again. Okay, and we are passing gamma score. Gamma is equal to GAMMA. Gamma is equal to G. Okay. So now we have instantiated where our kernel is RBF and gamma is G, and G gamma is gamma G. Okay, and we are using these values to check. Okay, where we get highest accuracy. So scores is equal to cross validation score. So we have to pass the algorithm inside it. Algorithm is SVC, and we have to pass X, comma Y. So X is our predictors and Y is our target. We have to pass cross validation, that is CV is equal to 10. Cross validation is equal to 10. And so we want scoring equal to accuracy. So scoring equal to accuracy. Okay. So now, so we have to take the average. Okay. So accuracy score or dot append of, I will take average scores. Okay. Scores dot mean. This will give the score, and I am going to print accuracy score. So let's wait. It will take some time. So we have got the values of accuracy score for the particular value of gamma. So where is the highest value? If you check, you could see that the highest percent accuracy score 96.8% for zero point 0.01 as the gamma value. So now let's do the plotting for this. Okay, for this gamma. So I will take this plotting. So here I will pass. So I want gamma range here, gamma range, and I want accuracy score. So value of gamma for value of gamma for support vector classifier. So let me print. So this is how it looks. So we are getting maximum value at maximum accuracy around here, 0.01. We have already seen, I mean, 0.01. 0.1, I guess. Okay, so here what is the accuracy? 0.01. Yeah, maximum accuracy we are getting between 0.01 and 0.1. Okay, so what we will do now? So what we can do? So xtick labels, let me mention it as plt dot xtick labels, xtick, xtick labels, xticks, 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 xticks of np dot a range of I will pass it as point 0.00.001 comma 100 comma 5 I will pass. Let me check. Okay, so you could see here, right? So we have got the plot. So if I had passed 0.0001 and check 0.0001. Okay, so we have got this kind of a plot. So now what we have to do is that, so let's do the optimization, optimized parameter from grid cells here. Okay, so we have to find the best parameters. Okay, so we have got at point 1, okay, at 0.01, we have got the highest accuracy score. Now let's do the optimization of the hyperparameter gamma. So we have done that. So now let's optimize parameter from grid search CV. Using grid search CV, we will do. Okay. So let's pass tune parameter as a variable name. Tune parameter is equal to, okay. So C, it can be C of np dot a range of value between 0.01 to 1 in the steps of 0.1, 0.01, 0.01. Okay. This can be our C, and kernel can be uh, linear. Okay. You can pass it as linear, or you can pass the C value to be the same since it is giving the best results. So C value remains the same, and our gamma here, we will pass gamma for this. So we are trying to find the best value. So gamma can be here. So gamma value is what we got. So 0.01, right? 0.01. So 0.01 we got maximum value. Okay. So gamma can be like 0.01, comma 0.02, comma 0.03, comma 0.04, comma 0.05, 0.04, 0.04, 0.05, and gamma can be this, and kernel can be RBF, radial basis function, or otherwise we can go with C value has same np dot range regularization parameter we have already got highest. Why we are taking C value in this range is because you have seen, right? I mean, here when we took the values between point 0.1 and point 1 and 2, we got maximum value at 0.5. Okay, so we are passing it from 0.01. So 0.01 I took, as we took 0.01, right? So 0.01 or point 0.1. So C range we took it from point 0.1. So we are passing it as 0.01 because we are going till point 0.1, right? So it's not a worry. Your research CV is going to take the best value. So till 1 it will go. So we are passing C value where it's giving the high accuracy. So we are getting high accuracy when it is between this range. So from a gamma here, I will pass it as the same set of values. Okay, so since gamma value is highest in over here, so gamma is highest in this range. 0.01 we have got the maximum value, so we have passed 0.01, 0.02, 0.03, and a regularization parameter. Can we have passed regularization parameter here? So you should have passed regularization parameter over here. Control X, Control V. Okay, so here we can pass a degree. Okay, so degree we have seen, right? I mean, for a polynomial. So now we will take polynomial as a kernel. Okay, so let me take a kernel as polynomial first. So polynomial kernel we have taken. So for that we need to pass the degree. Okay, so degree can be a set of values like 2, 3, 4, 5. So your Gridger CV is going to take the best value out of this. Okay, so I hope everything is fine. C degree, gamma, C value, and so we have set up the hyperparameters. Now we pass from sklearn dot model selection import. So what we are importing grid search CV. So we are importing grid search CV. So model model support vector machine is equal to wait. We are instantiating grid search CV, and I'm going to pass the parameter. So I'm going to pass support vector classifier, which is our algorithm. I'm going to pass x, comma. So we have to pass parameter. Sorry. So you have to pass tune parameter here. So we were passing it for x, comma y for this thing. So for which thing we are passing? We are passing x comma 5 for cross validation score. But here, if in this model selection package, we have to pass tune parameter, and then we have to pass cross validation score, and then you can pass accuracy. Okay. So now let me run this code. So from positional argument follows keyword argument. So there is some mistake, I guess. Let's check for a second. It's a CV tune parameter cross validation score. Give me some time. So I have to pass scoring equal to accuracy over here. So let me run this code. Yes, this is fine. So now let's do the training of our data set. So model underscore SVM dot fit of X train, comma Y train. So we have trained our model. So let me print the best parameters for our model. Okay. So best parameters can be given by grid search cross validation. Okay, grid search CV. So model underscore SVM dot best params, best underscore PARAMS underscore. Okay, so this will give us the best parameters for our support vector classifier model. So this is taking a lot of time to run. So I have been waiting for almost 30 minutes. So I had paused the video. So what I will do is that, so I will just explain the code that I have already have. Okay. So then what you have to do is that, so you will get the best score. Okay. So once you train your model using this thing, so you'll get the best score of 96%, okay, accuracy after performing. So the best parameters if you want. So you have to pass dot best underscore params underscore. So you'll get the best parameters out of the given parameters, okay. So out of the given parameters, we got C value to be 0.99 and degree to be 3, C 0.99 and degree to be 3 and gamma to be a value of 0.05. So we had already seen right here. So gamma 0.05, you could see right here, the gamma value we got here is a 0.05, okay. So then what we want, so we have already, we have kernel mentioned as polynomial, okay. So now what you have to do is that, so support vector classifier, you pass these values, okay. Kernel polynomial, C value 0.9 and degree is equal to 3 and gamma is equal to 0. You have instantiated and you have passed the parameters value, and then we are going to train your model, our algorithm using X train, comma Y train. So you have trained your model. Now do the prediction SVC support vector classifier dot predict of X test. So you'll get the Y prediction, then up matrix dot accuracy score of Y test you have to pass, and Y test you have already have, and Y prediction will pass. So you'll get the accuracy score to be 95.9%. Okay. So now what you can do is that now from SQL under matrix, you can import confusion matrix, classification report, recall score, and other parameters. Okay. So for first, what you have to do, so just consider this for now. Confusion matrix, conf matrix is confusion matrix of Y test Y prediction. Okay. So you got these values. Okay. So you got these values. So now what you have to do is that, let me say if it's run, so it's not yet run. So what you have to do now, so forget about this, okay? Forget about this. Just look at this, okay? Just look at this. So SNS.heatmap of PD.data frame. So they have passed confusion matrix over here. Okay, they have passed and anode is equal to true. Anode is, so values have been inside the okay heat map. So color map is yellow, green, blue. They have passed. Okay. And here you can have passed C bar is equal to false. They haven't done performance listing. Okay. So now what they have done is that title they have passed confusion matrix, and Y label they have passed actual label, and X label they have passed predicted label. Okay. So they have passed axis x-axis x.x-axis dot set label option at the top. Okay. Here they have mentioned. Okay. So this is all about the heat map that we have drawn with the confusion matrix inside that. Okay. So now we have to get the recall score. So recall score, for that you want to pass Y test comma Y prediction. You will get recall score. So pass. So we have already imported recall score, right? So from here, so we have imported recall score. So we will get recall score by Y test by prediction. Similarly, you can get ROC curve as well. Similarly, precision score and ROC AUC curves. Okay. So precision score they have passed here, and Y test by prediction. So you get recall scores to be 97.2% and precision score to be 94.9 or 95%. Okay. So for getting this ROC AUC curve, so you have to pass false positive rate, comma true positive rate, comma all the other parameters is equal to ROC AUC curve, that is ROC curve, sorry, ROC curve of, so you have to pass Y test, comma Y prediction. Okay. Once you pass Y test, comma Y prediction, you will get false positive rate and true positive rate. So pass PLT dot plot of false positive rate, comma true positive rate, and label you have to pass AUC is equal to. So we have to calculate AUC rate, area under the curve. Okay. So ROC AUC curve of Y test, comma Y prediction will give you AUC, area under the curve. So pass it as in the form of string, and then you plot the PLT dot legend location. You give it to the right bottom. Okay, location is equal to 4. So then you will get the plot with the accuracy of 95%. Of this area under the curve is 95%, which is a good score. Okay. Then what you can do is that, so let me check if it's done. No, it hasn't. So then you have to, what you have to do is that, so you have your data, right? So just predict for the whole data set now. Okay. Data underscore prediction is equal to predict for whole data set. So then you will get see these values. Now what you can do is that data of predicted, now add the column to your data. Okay. So you have data, right? So here is your data. So data, right? So data, you have in that data you had actually dropped on a column, right? Okay. So what you can do, so you can mark data of predicted is equal to np dot where. So if y is equal to data dot underscore prediction, then value will be this, else the value will be y. Okay. So we have a new column, data dot head, where we have a predicted value as 1111 and 0000, and we have a label as well. What you can do is that you have to drop this label from this data of predicted, drop that one, and then replace the data of predicted dot replace value 1 by male, value is equal to data of predicted dot replace, to replace 1 by male. So replace is 1, value is male, is true, in place is equal to true, and data dot predicted data replace, to replace 0, replace by female, value is female, place is equal to true. So you can just drop this label, or it's fine. I mean, a label column, you can just drop it. Okay. You can just drop this, but this will be fine because it will just compare this label value with the predicted. I mean, it's not required, but yes. So this was all about the building of a machine learning model, which is support vector machine. So we have completed all the machine learning model we have. So you can use any of the machine learning model based on the kind of data set you have. So thank you for attending all the sessions if you have attended. So I will be bringing the next further class on some other topics as well. So keep watching my channel, and you will get some notifications if you subscribe. Please subscribe my channel for other videos as well. So thank you so much.